Before beginning the next lesson, try this warm-up. Solve for x. Okay, so pause the video, try it, and come back to see how you did. Hopefully you saw that this is a right triangle. Now I went ahead and I labeled opposite, adjacent, and hypotenuse, going back to my trigonometry skills. And I know I want to find the adjacent side, and I have the hypotenuse, adjacent and hypotenuse, so I'm going to use the cosine ratio. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. So my angle is 53 degrees. My adjacent side is x. My hypotenuse is 5. Now I can solve for x. Multiply both sides by 5 to rearrange. X is equal to 5 times the cosine 53, which ends up being 3 meters. Okay, this is a trigonometry skill that we are going to use as we go through the next lesson. In the previous lesson, we looked at geometric vectors. Well, this time we're looking at algebraic vectors. So this is just a different way of looking at vectors and a different way of finding the resultant. Okay, so we're basically going to accomplish the same goals here. We're going to represent and draw vectors instead of geometrically, algebraically. And then we're also just going to perform the operation required to determine the magnitude and direction of the resultant vector. Okay, so we did that in the last video using geometry. This time we're going to use algebra. The first thing I want you to understand is that any vector can be separated into its x component and y component. So for an example, here's my vector u in red. It's going right and then a certain degree up. I can separate that into different components. So I have the horizontal component, or what I'm calling the x vector, and the vertical component, the y vector. Now, this is going to be important later when we actually solve some problems, but if you can figure out what the x component and the y component are, it can make finding the resultant of two vectors a little bit easier sometimes. So in order to find the x and the y components, you need to know what this vector is, okay? And you need not just the magnitude, but also the direction. So if we know the magnitude and the direction, so this angle in here, we can figure out the magnitude of x and y using the math similar to what we did in the warm-up. This is a right triangle. We can use sine and cosine ratios to figure these out. So here I have it worked out to find the magnitude of the x component, the magnitude of the y component. Okay, so here's my angle. This is the adjacent side. This is the hypotenuse. So cosine of my angle is adjacent over hypotenuse. I just rearrange this, multiply both sides by u. Okay, so the magnitude of the x component is equal to the magnitude of your vector multiplied by the cosine of the angle. Similar, to find the y component of your vector, you use the sine. Sine is opposite over hypotenuse. Rearrange, we get the y component magnitude is equal to the magnitude of your vector multiplied by the sine of the angle. Okay, so that's the magnitude of your x and y components. Now, if I want to write the vector itself, I have to have an indication of direction. And that's where unit vectors come in. So we're using symbols here, I with a hat, J with a hat. I'll just call them hats for lack of a better word. But if you recall in the first lesson on vector basics, I talked about unit vectors. So unit vector on the x-axis is in the same direction as your x component, but just with a unit of 1. Same with J, except it's on the y-axis. Okay, so if I want to indicate the x vector with a direction, I'm going to multiply the magnitude by I hat to indicate that it's going in the direction of the x-axis. Similar with the y vector, has the magnitude of the y vector multiplied by j hat, so times 1, but then it indicates the direction. It's going on the y-axis. Okay, now what do I do with this? Well, u, my vector, my original vector, is x plus y. If I add the x component and the y component together, u is the resultant of those, okay? So x is this, y is this, so x plus y is this plus this. That's what I have written here. Okay, so write this down. This is a good formula to have in front of you. Any vector can be written in its x and y components. Okay, keep that in mind. Now let's go back a bit. Let's say you don't know what the angle is here, but you know your x and your y components. Well, you can figure out the angle using trigonometry again. Y is the opposite side, x is the adjacent side. Opposite, adjacent, we can use tangent. So tan theta is opposite over adjacent, y over x. The magnitude of y divided by the magnitude of x is the tangent of my angle. So to get the angle, I take the inverse tangent. Okay, so this is another formula that you should have handy so that you can figure out the angles. Now we'll work through a few examples. If the magnitude of vector u is 10 units and the magnitude of vector v is 5 units and the angle between the two vectors is 30 degrees when placed tail to tail, determine the resultant. You might recognize this example from the previous lesson. It's the same example. We're just going to solve it in a different way. In the previous lesson, we used geometric vectors. So we used a geometric representation of the vectors. This time we're going to use an algebraic representation of the vectors. So here's what it looks like. Here's vector u, and we had 30 degrees between u and v. Okay, so to solve this problem algebraically, I'm going to write each vector in its algebraic form, and then I'm going to add those together, and I'm going to get my resultant that way. So let's start with vector u. U can be written as the x component plus the y component. So if we start with x component, well, vector u is perfectly horizontal, so it's perfectly on the x coordinate. So if the whole thing is 10 units along the x coordinate, then I have 10 I hat as the x component. Now I have to add the y component. Well, there is no y component. It doesn't go up vertically any amount. So the y component is 0 j hat. And here's just a reminder of the formula that I derived on the previous part of this lesson. So any vector is a combination of its x component plus its y component, and that's what I did here. Now I'm going to do a similar thing with vector v. Okay, so if I think about vector v, well, it goes right and up. So we have a horizontal, an x component, and we have a vertical, a y component that we have to figure out. Now I do have this angle down here, so I can just use my formula. Okay, so for vector v, the x component, the magnitude of the vector multiplied by the cosine of the angle, which is 30 degrees. So this is the x coordinate of vector v. Now the y coordinate is the magnitude of my vector multiplied by the sine of my angle. So 5 sine 30 degrees times j hat is the y component of my vector. Okay, so if I want to find the resultant of u and v, I need to add u and v. So this is how I'm going to do it. I'm just going to add the x components, and then I'm going to add the y components together. And then what's left down here will be the x and y components for my resultant. So in my calculator, I'm just going to write 10 plus 5 cos 30, which is about 14.3. So the x component of my resultant is 14.3 I hat. Now the y coordinate in my calculator is 0 plus 5 sine 30, which is 2.5. So my y component is 2.5 j hat. Okay, so my resultant, u plus v, is equal to 14.3 I hat plus 2.5 j hat. So I have the x component and the y component. So now that I know my x component and my y component, I can make a little triangle, and I can figure out the magnitude of my resultant, and I can figure out the angle for direction. So to find the magnitude of r, I can start with Pythagorean theorem. A squared plus b squared equals c squared. Take the square root, and I end up with this as my answer. Next, I'm going to figure out the angle. Remember, tangent of the angle is opposite over adjacent. And I just have to take the inverse tangent to find what the angle is. So if I do that in my calculator, I get this. And so I can say the resultant vector, so r is 14.5 units east, 9.9 degrees north. So we arrive at the same result as when we did it with the geometric representation, except this time we did the algebraic representation, and we got the same result. Let's try another example. This time we have a grid, okay? So determine the resultant of 3u minus 2v plus 5w. Now, I did a similar example in the previous lesson where we actually just took these and we drew it on the grid, and then we figured it out geometrically. We're going to do this algebraically though, and we're going to do it in a similar way as in the previous example. We're going to take each vector, multiply it by its scalar value, multiplier in front. We're going to find the x and the y components of each, add all the x components together, add all the y components together, and we'll get our resultant that way. So this is how I'm going to set this up. I want 3u, so I'm going to write the x and the y component for 3u here. I'm going to subtract 2v, so I'm going to write the x and y components. 5w, same thing, x and y components. Add all the x components, add all the y components, I end up with my resultant vector. Now, don't worry about these coefficients in front. It's actually pretty easy. All I have to do is this. So I put the coefficient in front, and in the brackets, I'm just going to write the x and y components for u, v, and w. So let's start with u. U only has a horizontal component, so it's 1, 2, 3, 4 units in the positive x direction. So the x component is going to be 4i hat. There's no vertical component, so there's no y component, it's 0j hat. Now v, 2 units down. So what's the x component? Well, there is no left or right movement, so it's 0i hat. Now the y component, it's going downward, so minus 2j hat. Now w, okay, let's look at the x component. Well, x component, it's going 1, 2, 3, 4 units to the right, so 4i hat. And the vertical component, it's going down 1, 2, 3, 4, so minus 4j hat. All right, now we want to get the resultant, so we're going to add all these together. Now, this is where you got to be careful, okay? The coefficient of 3 in front of the brackets means each term is multiplied by 3. So we've got 3 times 4 and 3 times 0 here. Minus 2 times 0, minus 2 times minus 2, 5 times 4, 5 times minus 4. So make sure you do all those multiplications when we go through this. Okay, so let's look at the x components. If I add all these x components together, I have 3 times 4, which is 12, minus 2 times 0, so 0. 5 times 4 is 20. So I've got 12 plus 0 plus 20i. That's 32i hat. Okay, now we do the same thing with the y components. We have 3 times 0, which is 0, minus 2 times minus 2, which is positive 4, 5 times minus 4, which is minus 20. So we have 0 plus 4 minus 20. And that's minus 16 j hat. Okay, so the resultant vector, 3u minus 2v plus 5w is 32i hat minus 16j hat, x and y components. Okay, so now we can do like we did in the previous example, where we're going to use Pythagorean theorem to find the magnitude of r, and then we're going to use that inverse tangent to find the value of the angle, and then we can write the resultant vector. R is 35.8 units east, 27 degrees south. I know it goes east and south because my x component is in the positive or east direction. My y component is in the negative or south direction. So it goes east and then 27 degrees south. Okay, here's my last example. If u plus v plus w equals r, determine u. Okay, so I know the magnitude of v, w, and r. I also know the directions of each of them. Now this would be very difficult to figure out geometrically, but it's not as bad when we do it algebraically, so I'll show you what we do. I start off with figuring out how to calculate u. Well, I know r is u plus v plus w. If I rearrange to solve for u, well, subtract v, subtract w from both sides, I get r minus v minus w. Okay, so I know to calculate u, I need to take r, subtract v, subtract w. I'm going to set this up algebraically. So I'm going to start by setting up a table like I did before. I'll write out the x and y component for r, the x and y components for minus v, the x and y components for minus w. Just watch out, the minus sign means you're reversing direction. Okay, then when I add the x and the y components together, I'll get the x and y components for u. So why don't you just try to figure out the x and y components for u on your own using the information given up here. Pause the video, try it, and then we'll come back and I'll pick up from here. Okay, here we go. So r is 15 cos 45i plus 15 sine 45j. Negative v, so I've got a negative sign in front, so let's just look at the x and y components for v, okay? It goes to the left 10 units, so that's minus 10i hat. It doesn't go up or down, so that's 0j hat. Minus w, we've got a minus in front, x and y for w, well, it goes to the right and up, so x is positive and y is positive as well. Okay, now when I add these together, 15 cos 45, okay, now minus 10, okay, the double negative, so I'm plus 10, and then minus 25 cos 75. It should end up being 14.1, so I've got 14.1 I hat for the x component. Same thing over here for the y components. I'll have 15 sine 45 minus 0, okay, minus 25 sine 45. So don't forget the minus sign in front. It should end up being minus 13.5 j hat in the y direction. All right, now that you've got the x and y components for u, I want you to try to figure out the magnitude and direction for u. So pause the video, try to get the magnitude and direction, and check back in when you're done. To find the magnitude of u, I need to use Pythagorean theorem again, using my x and y components. I get 19.5 units. And then tangent is opposite over adjacent, so the y component over the x component. And take the inverse tan to get the angle. It's about 44 degrees. I know that I'm going in the positive x direction and the negative y direction, so I'm going to the right and down, or east and south, which that's my preference to right. So I'm going 19.5 units east and then 44 degrees south. All right, so that's practice with algebraic vectors. Sometimes using a geometric method works better than using an algebraic method, and vice versa. So really you just gotta practice and use whatever works. So as you're working on the practice questions, please reach out if you need any help, and I will do my best to help you.